Hello and welcome to another Beer and Code. Today, cheers, we are continuing our new series on Kotlin. Kotlin, the new language, newish language for the JVM. And we are going to be continuing working on converting JDapper here from a Java project to a Kotlin project. And today, today we are going to look at sort of the file structure a little bit, and then how to declare classes, constructors, methods or functions, and variable declarations and typing and things like that. Let me check my notes. Yeah. So it's going to be some high-level, just general Kotlin syntax and sort of how it compares and relates to Java, and what are similar and maybe what are some differences. All right, so let's start at the top of the file. All right, at the top here we have what should be familiar to Java developers, and that's the package declaration. One thing you'll notice is that there's no semicolon. Other than that, it's the same, and that's actually true for all of Kotlin. In Kotlin, semicolons are optional. So because they're optional, you should never use them because it just has no value. It's extra typing. So in Kotlin, we don't use semicolons. I've not ever run across a place where I would want to use one. So one other thing that is different about Kotlin packages is, unlike Java, you can create, or you can declare that your package doesn't match the folder structure, unlike Java where it is required to match. I don't think there's any really great reason to do this. You should still be disciplined and structure your code, packages in directories, I feel, but Kotlin lets you declare packages as you like, so take that for what it's worth. Alright, so the imports are also nearly the same. There is a little bit more functionality you can do in Kotlin that you can't do with Java, but we're not going to go into that right now because it's not super interesting or incredibly useful all the time. The next big change that we're going to talk about is the class declaration and constructor declaration and member variable declaration, and those are all very closely tied together in Kotlin because of this very, very terse syntax. So this line 9 here is doing a lot. Line 9 here is both, or is doing three things really. It's declaring a class called JDapper, and by default the class is public. That's just how Kotlin rolls. You can add modifiers if you spell them correctly. Pirate, P-R-I-V-A-T-E. Alright. You can add modifiers. Most modifiers are similar to Java modifiers to change the access level of your classes. So you class name, JDapper, and then this opens the body of the class over here. So between this, we have something that does look very different from Java. And what we see here is a primary constructor definition. So what this is doing is it's saying you can new up JDapper with this as a constructor. Just a constructor that takes a single value that is of type connection. And what we're seeing also here is the different way that Kotlin defines its variables. So in Java, you would have, it would look like this, where you have type and then name. But in Kotlin, you do it the other way around, where you have name and then type. I'm not sure the exact reasons as far as language design goes and why you would do that, but that's how Kotlin does it. You get used to it. I like it. So this is saying I have a constructor that takes one variable called connection that is of connection type. And that's what this is. But also, because I've declared that this is a private val connection, I'm also saying that this is going to initialize a value called connection, a member value called connection in my class. So if you look down here, I'm accessing it because it's a member variable. if I remove this part here, this private val, now what this is doing is it's saying this is a constructor parameter, but it is not a member variable. So then what you would do, and this is actually how you can add more functionality to your constructors in Kotlin, is you have an init block. And the init block is where you do your construction if you need more than creating member variables. So what you can actually do is you can declare a private member value connection here, and you can say this.con equals con. So what this is doing is the same thing as we had before, but in more lines of code. But I just want to illustrate what that line of that constructor is doing. It's declaring this value connection. It's also declaring that it is a constructor parameter, and it is initializing them in this way. And actually, so IntelliJ is saying that the initialization can be joined with assignment. So we're going to listen to it. And it got us part of the way here, but actually, there. It'll put it all back together and saying, hey, you really didn't need all that extra code. Let me help you, and there we go. So, once again, we have our class, JDapper. Now this is both setting up a member variable called connection and a constructor parameter called connection. So, in that one line of code, there's a lot going on, but I find it great. It removes a ton of boilerplate code. It makes things a lot cleaner. All right, so next we have a function or a method definition within the JDapper class. So when you declare a function like this is essentially declaring a public method called query. But before we get into that, I'm going to talk about this throws for a brief period here. So in Kotlin, unlike Java, you have 0 checked exceptions. So you don't have to declare when you're throwing a checked exception. You don't have to catch them and deal with them. Kotlin just removes that restriction altogether. So it makes it so you have to think about it less, which is really nice. So we don't actually even need to annotate it with that, because there's really no need anymore, because there's no such thing as a checked exception. They're all unchecked exceptions in Kotlin, and I find that to be much better. All right, so now within our function definition here, or our method definition, it's going to look a little bit different than Java, and let me kind of talk about the structure of it here. So function, or fun is the keyword to always declare that you're defining a function. And then this is a generic parameter, so of type T. You can add, wow, I can't type, sort of bounded parameters for your generics. And we're not using that here though. This is the name of the function. And then this here, this is similar to Java. It's the list of parameters that this function takes. So just like the constructor, it's going to follow the pattern of name of the variable and then the type of the variable. Name of the variable, type of the variable, it's a generic type. And then name of the variable, type of the variable. In this case here, this is a vararg, so it's similar to Java's like params syntax. So this is saying you can have a variable number of parameters in this method call. And then any here, any is essentially object. It's Kotlin's version of object. So if I actually call an object that says this class shouldn't be used in Kotlin, use Kotlin.any instead. Okay, IDE, if you say so. So they're roughly equivalent, but any is built specifically for Kotlin. So that's what you should be using when you're in Kotlin. And then you'll see this colon here and a type. And what that is that's the return type of this function. So unlike Java, where you declare your return type at the start, in Kotlin you're going to declare your return type at the end. I think it makes more sense this way because you're saying, okay, I take in this and this and this and this, and then I return this. Where in Java it was kind of backwards. It says, all right, this function returns this, but it takes in these things. So this seems to flow a little better, but that's my personal opinion, and it doesn't really matter much. If you were to remove and leave off the type declaration for the function, that means it's returning nothing. It's returning void, or actually unit in Kotlin. So if you don't want to return anything, you can leave that off, but in this case we're going to return our list. So that is generally what a function looks like. And now functions can live in many different places. You can actually declare functions outside of classes. And then you can so you can declare functions outside of classes. You can define functions inside of other functions. So Kotlin is much more flexible than Java. You'll run into cases where you'll use these. They're sometimes useful, sometimes not. I would try to limit the number of places where you're using functions outside of classes, because it's still usually smart to encapsulate that sort of information. Alright, so next we're going to talk about val versus var. So inside of this function here, I'm declaring a value called results, and it is an array list. What this is saying is val results is final. It's read-only. You can't ever set it again. So if I go results equals array list, it's going to give me an error here. Also, this is a constructor. We'll talk constructor invocation. We'll talk about that in a second here. So it's saying val cannot be reassigned because in Kotlin, val is final. So it really sort of helps you be safe about your code. If you want a variable, you use var. And you see how Kotlin actually underlines this, saying it's a variable instead of just a value. So the IDE kind of gives you hints there. But now, so since it's a variable, I can assign it here, and then I can reassign it here. Usually it's best to use val, unless you have a really good reason to use var. So that's val versus var. In this line, also what we're doing is we're invoking the ArrayList constructor. So in Java, this would look like this, more or less. ArrayList of t results equals new ArrayList t. So this is largely what this would look like in Java. So new is a constructor invocation. That's what's happening here. And we don't have to declare the type anymore. So that is, these two lines are sort of this is the Kotlin equivalent of this Java line. Okay, so now we've looked at how to declare variables, and one thing that you'll notice is you don't have to define the type of this variable or value here. Kotlin does not make you do that. Kotlin is smart. It will do type inferencing, so it knows that when you invoke the constructor of ArrayList, it's going to be ArrayList of t type. But if you want to be explicit about it, you can give your variables types here. So you can say this val result is of type ArrayList. So you can see here that this syntax is the same as this syntax. So it's just the way to declare a variable and give it a type. But like I said, in Kotlin, you don't need that, and you really should not do extra things that Kotlin does not require you to do. Kotlin likes things to be terse, succinct, so I would leave off the typing unless there's a really good reason for it, which sometimes there is. Alright, so now you've seen how we declare variables and values. The final thing I want to talk about is nullability. And Kotlin introduces this sort of null safety element to your code, which means I can't actually define or declare that this string is ever null. So I can't say that a string is null, because by default in Kotlin, everything is not null. What I can do is and this is also an example of why you would want to type your variables, by the way. What you can do is you can add this question mark. And this question mark applies to every variable or every type in Kotlin, saying this can be null. So let's give it an actual value here. Hi, oopsies. And then if we make this a variable and try to assign null to it, it will say null can't be value of type not null string. So it's going to make sure that if you have a string type, you'll know that it's never null, which is very, very nice. But I can also go like this and make it a nullable string, and now we can't be sure that it isn't null, but we are allowed to assign null to it if you want to. There are a few ways, once you do have something that can be null, to get values out of it. So I'm going to say val not null equals, so I can't take a string question mark or a nullable string and try to assign it to a string type that is not null. So there's two ways around that. One way is to use the exclamation point, the double bang operator, and this is actually giving me an error. It's saying, hey, you're going to have an exception here, because what this does is it turns a nullable type into a not nullable type by just saying it's not null, but if it is, it's going to throw a null reference, null pointer exception. Another way around it is you can use a like it's called the null coalescing operator, I believe. Question mark colon. And what this is saying is, so if string is null, return this value. So this way, our not null string will either have the value of string, unless it's null, it'll have this value. So that's another way to get your nullable types into not nullable types. Let's get rid of all of that code. All right, so let me make sure. Oh, right. So one thing I did forget to mention here is, so say you want to be able to support multiple constructors for your class. Well, you can do that by declaring your constructor here. And one thing that your constructor has to do, if you look, it says primary constructor call expected. So you actually have to make sure you call your primary constructor. Actually, I can't pass in null here because it's not nullable. But you have to call your primary constructor with some value. So if I make this nullable connection here. So this is how you would define more constructors in your class. Simply by saying constructor, and then you would put any parameters you want here. In this case, I want a default constructor that will then call the primary constructor with a value. So that's the way you can actually declare multiple constructors in Kotlin. It's really nice and succinct. In this case, I can leave off the method or the constructor body because it's empty, but I can also like do some functionality in here as well if I want to. But if I'm not going to do anything in the constructor besides pass some values into the default or the primary constructor, you can leave the body off, and it keeps your code nice and tight. So, I made this nullable. Alright, so I hope you learned something about constructors and classes and general file structure and methods. We kind of went through a lot because there's a lot of changes in Kotlin. But I hope you guys learned a bunch. Let me know if you have some questions or if something wasn't clear in the comments below. And stay tuned for some next video or some future videos on Kotlin where we talk about Lambda syntax, higher order functions, Java interop, and a bunch more cool things about Kotlin. So, once again, thanks for listening or watching. I really appreciate it. And cheers. See you next time.